Hello, welcome everybody. This is ELEC291 Lab number 6 demonstration. And in this lab, we were tasked to make a embedded device that will read temperature and then give it to the computer using the serial port. And the temperature from the serial port will be used by Python to generate a real-time plot called strip chart. So right now, the system is this is the temperature sensor. And right now, we are plotting the temperature. And as you can see in the screen over here. So this is the temperature plot. And in my temperature plot, we have three features. First, the range, so it goes from 15 degrees to 45 degrees, and then it goes from 29 degrees to we have a minimum temperature, max temperature, and temperature. So temp basically is the current temperature, the max is the maximum temperature ever recorded, and the minimum is the minimum temperature ever recorded. So if I touch the sensor, let me see here. So I'm touching it, and right now, and you can see the temperature data going slowly up. Okay, yeah. So you can see the max temperature is also increasing. It's around 32.434, and so if I stop touching it, it's going to cool down, and you can see that the graph is slowly going down. So this is done. Now I'm using this Python program, and it's printing the data. Yeah. So as you can see, this is the temperature. Now you're wondering, well, that was just the temperature. Now what's all these other wires? So I am also using an inertial measurement unit, MPU6050, to control the angle of elevation and rotation of these two servos. So check this out. If I tilt it up, the angle goes up. If I tilt it down, it goes down, and if I tilt it sideways, it turns sideways. So this is also an extra feature of my lab. So this works on I2C protocol. Let's look at the wiring first. So the MPU 6050 is using 4 wires. So the orange and the brown, or the red and the brown are for the serial clock and data lines, and the yellow and the orange are the ground and VCC. These are the serial clock and data lines. These are the ground and VCC. And then we have a status LED that tells us the current mode of operation in the device. And then we have our microcontroller. This is based on PIC30. This microcontroller is PIC32 MX130, 28-bit microcontroller, 632 bits. And then we have 3 push buttons used to take inputs from the user. And then we have some servo connections. So these are +5 to the servo, and this is the +5 volts going to the temperature sensor over here. So +5 volts goes into here. This is the red wire is the temperature sensor, and the black wire is the ground of that sensor. And then the green wire is the analog input from the temperature. Then we have these wires are actually for the programming of the board, and then we have some capacitor that is basically the setup of the board. Then we have these yellow and orange wires. These are the servo signals. I'm using timer number 1 to generate the PWM signal needed to control the servos. So as you can see, you can control the yaw and the pitch, the pitch and the roll. And so if I go up, this is roll, as you can see over these. So this is the y-axis, and this is the x-axis rotation. So this is the roll, and this is the pitch. Since this IMU only has a gyroscope and an accelerometer, I cannot get the yaw angle or the z-axis angle accurately without drifting of the gyro. So I did not implement that. Let's look at how this system works. So right now, as you can see, this LED blinking. Take a note at this blinking rate. So it's blinking at a rate of 1 second. So this tells us that we are currently outputting the serial data, and this means that the temperature output is being outputted in the serial monitor. Now watch what I press this button, and then I press this button. So now the blinking rate is quite fast. This basically tells that the temperature data is not being plotted, and you can also see that the chart is paused, and this is also paused. So the way my Python script decides whether to plot is not, before sending temperature, I send this key, and then the Python checks it. If it reads the line, if the line is equal to the key, then the next line immediately is the temperature value, and then I get that using that. So that's how I'm checking whether the data in the serial monitor is correct or not, the temperature is printed or not. So let's close this plot. Yeah, it become non-responsive because I stopped it. It just takes a while to close. Okay, now let's open the serial monitor. Okay, so you can see focus. Yeah, so these are the x and y angles, and RP15 is basically the pin, the output, the input. This is basically the state of button 15, not useful for now. So if I change the x angles, sorry, if I change the y angles, you can see the change in y angles. The data in CL is plotted every 600 milliseconds or 300 milliseconds, depending upon what you want. And so to show you again, if I enable the temperature outputs, I can show you. So now you can see over here that temperature is being plotted at a rate faster than the angle. So every 100 milliseconds we plot a new temperature value, whereas every 500 milliseconds we plot a new angle value. This is to reduce the load on the serial and the Python script as well. So now if I run the script, it will show the graph, but I don't want to run because I'm using the serial monitor. So please focus. Yeah, now let's look at some of the features rather than of the IMU and what I have implemented. So yeah, the blinking is one feature, but tells us the user that what mode we are currently in. Let's switch off the temperature measurements. Okay, so fast blinking mode means we are in the IMU and we don't put anything. Now as you know that we can control the angles, right? Now we have a calibration feature as well. So when you boot the device up, so the Servos goes to the rest angle and it goes calibrating IMU, and we calibrate the IMU. So we need to keep it very stationary at this moment. After this, we calibrate the accelerometer values. So basically in the calibration part, please focus. Yeah, in the calibration part, we basically take 2000 readings and then average them out to get the average offsets, and then we use that. So this bar basically tests the progress of the calibration, and once it reaches the 2, we can start getting the measurements, and should be done any moment now. Okay, yeah, so this goes up and now we can use the device. So yeah, okay, so this was basic calibration. Now suppose you wanted to calibrate how far the servos go, so you can also calibrate that using the servo calibration. If I press this button, it says calibration of angles for servo, press button 1 to start. So this basically is a state machine which takes the x max angle, then the x minimum angle, then the y max angle, and the y minimum angle, and then use that to map the output of the servo. So I'll just show you. It just takes like 10 seconds. So you can see a loading bar as well. So right now the LED is blinking. If I press this button, it stops and basically tells that you need to give. So it's difficult to do that using while holding the camera as well. So I try my best to do that. Okay, yeah, so right now as I'm not able to hold this, we might not get the best calibration, but I'll try my best. So I press this and this is stop. You can see the serial monitor saying calibrating X max. Please focus. Okay, and you can see the LED starts blinking, so it does now to put it in the opposite direction. And okay, now I need to press the button. Oh, this is a bit difficult. Let me hold it like this. Okay, yeah, so LED stopped and we see the next calibration. It's done. Now the Y max angle. So I'm going to hold it like this. So I'll just hold it. Okay, yeah, so we are getting the Y max angles done. Now let's get the Y min angles. Okay, servo calibration is done, and you can see that it's become erratic because either told you it's difficult to calibrate it. Yeah, so this was the calibration feature. If I could have done it using 2 hands, I could have done it better. I need to orient it like this and then press and hold. So you can see the LED is blinking, not blinking, which basically tells that it's sampling, and it's blinking again, that is done. And you can also see in the serial monitor that there was a bar that tells us like what is the percentage. Now we need to orient it like this and press it again. It stops blinking LED and you can see there's a bar on the serial. Okay, done. Now orient it like this to get the Y angles. and orient it like this to get the minimum of the y angles. This is the last step to get this. This is basically a state machine that is being implemented in a calibration sequence. So now you can see, so you can see it's faster and responsive. And yeah, so there is some error in the gyroscope. I was not able to get rid of it permanently. I think the best implementation would be to implement a Kalman filter, but I don't know the math, and it takes a lot of time to implement it, so I haven't implemented it. But let's look at some ways to get the accurate measurements. So I just I just reset this device so that we get to the original settings. So let me explain the types of filtering that I'm doing. So we are doing two types of filtering in this device, with actually three types of filtering. So first filter is the to prevent the gyroscope from drifting. As you know, there is a serious problem of drifting in gyroscope. So that's why I use the accelerometer angles to prevent the gyroscope from drifting, and for that I use a complementary filter, which can be adjusted using the button. Once we get this loaded, I'll show you how to calibrate that as well. I can also use a moving average filter that will help us to smooth out these angles, and we can do that to make it more to make the angles go smooth. So as you can see, it's back. Now let's change the sensitivity. So you press this button, it shows weight change mode. Basically, weight is the percentage of accelerometer and the gyroscope, what percentage of accelerometer and what percentage of gyroscope output to take in the end. So if I press this button, this increases the weight, if this decreases the weight. Generally, if you increase the weight, the gyroscope is more prominent, and the thing is, like, the drifting will start to see, and it takes a longer while to respond to changes in angle. So it goes at max till 1. We need to go back. Yeah, okay, so now I set this. Now I press this to set it, and as you can see now that the rate of the gyro is too slow. It's still actually pretty okay, but sometimes it is slower than the previous. Now let's decrease it and show the effect of accelerometer. So I press and decrease it. So 99989 and okay, let's see now, and you can see it's quite fast. But the problem with accelerometer is it's very sensitive to small changes, and so you need to pay a price for getting more. So ideally we should need to get a perfect weight that balances the accelerometer's noise, as well as not preventing the gyroscope from drifting as well. So let's run moving averages. So if I press this button and press this button, we see moving averages on, and now it will be a bit stable. See, keep in mind that this is the same accelerometer setting which was jerky like a few seconds ago, and it's quite stable. So moving average is basically taking the last 5 values of the sensor output and averaging them and getting the next value as the average. And the window for measurement is around 5 values for each sensor. I think that's it for this demo. If you like the video, be sure to share it with your friends and give it a thumbs up. I would love to hear what you think about this in the comments below. So thanks for watching, stay creative, and I'll see you in the next video.